Hello, everyone. I'm really happy to be here. So yeah, thank you for introduction. My name is Aragats. I'm senior software engineer at AtFarm/Yara, and also I'm a Ph.D. student at Hasso Plattner Institute. And I'm here today to give a talk about the farming, about digital farming. And if you by any chance bias about the farming and you think that farming has nothing with technologies, I would be happy to change this opinion during the next 10-15 minutes. Meanwhile, for everyone, I'm going to show what is actually happening now in the industry and which technologies approaches are used to move from traditional farming to the digital farming. Oh, I forgot my... Good. So, yeah, actually the statement that farming is quite far away from technologies or from digitalization is reasonable because farming has resisted digitalization a long time. And only last years, they started to look at the technologies and approaches, how to move from traditional farming to the digital farming. Traditionally, farmers really rely on their own experience that's developed by years. And so it means, just imagine you're a farmer and you have a small field, let's say 10 hectares, and you grow there potato or corn. And you do it seasonally or yearly, so you do it repeatedly, and you gain experience. For next time, you will get better harvest, next time you will get better harvest, and so on. And generally, to get the good harvest, it means to do better fertilization. But if you're a smart farmer, you also would like to save money, so you don't want to over-fertilize your field. That's why the strategy will be, go to your field, check your field condition, check the vegetation, biomass, and then decide how many fertilizer to put in this area and how many fertilizer to put in the other area. By other words, you create some kind of application map that shows the distribution of fertilizer over your field. You can imagine that's quite hard and routine work, especially if you have really, really huge field, or if you have many fields with different crop types, because every crop needs its own strategy. But you want to do it. You want to get the good harvest, and you want to save money, because fertilizers are expensive. So, but what if someone can help you? Someone who is watching on your field at any time during the year. Someone who has a view on your field, like this one. Someone who is top of us, someone there. No, I'm not talking about God. I'm talking about satellite. Yeah, satellite... and actually this satellite and many other satellites around the Earth, so his brothers, sisters, many kind of relatives flying around the Earth, and they're helping us a lot. Thanks to them, we have GPS navigator. That's why we came here without any troubles, I hope. We found this venue on the Google Maps, Apple Maps, Bing Maps, depends what you use. Thanks to them, we have satellite TV, we have internet in remote areas. So actually, they collect a lot of data around the Earth and send back to the Earth from where they were sent. So let's ask them, because we can see that they're actually helping us a lot, a long time, and they care about us. So let's ask them to help us with our challenge, to make farming digital and do fertilization variably. But I just need to say that not every satellite can help us. And we can't ask random satellite. We need to ask some really concrete satellite, which is called Sentinel. Sentinel actually is some kind of Earth observation mission from ESA. ESA is European Space Agency. And this satellite has capability to provide multispectral data in 13 bands, like visual, infrared, shortwave infrared. So you can see some of them, I think 9, 8 bands with their spatial resolution, 10 by 10, 20 by 20, 60 by 60. And actually, we are going to use this information to solve our challenge. But first of all, let's look what a satellite sees. Generally, satellite sees Earth at any time. So it's some kind of screenshot from the Google Maps in satellite image in high resolution. You can find that on Google Maps as well. What is farmer sees? Farmer sees a field, some area with boundaries, and he's actually interested exactly on this area, not about the Earth. Entire Earth. And for this area, Sentinel can provide recent satellite images. It will be in low resolution, so not like in Google Maps with high resolution and low resolution, but it will be recent. Recent means it will be taken from today, yesterday, 3 days ago, a week ago. So it means you can check your field condition at any time without going to the field. So even now you can see where you can some vegetation, where you don't have vegetation with this image. But can we go further? And farmer is interested in biomass. Biomass, I mean, in vegetation. And we can do it as well. Based on the data from satellite, we can calculate NDVI. It's kind of standard vegetation index, which shows you distribution of biomass on your field. So here you can see the formula, quite simple, just red band and near-infrared band are used. But here you can see where you have low vegetation, where you have high vegetation on your field. You already can make some kind of planning of your fertilizer. But let's go further and make more detailed biomass information. For that, we need to calculate N-sensor biomass. And this index is calculated based on the vegetation bands from Sentinel, which has resolution 20 by 20. But the good point is that now you have more precise information. I don't know whether you see from backside, but here you can see, if you come to closer, difference between each pixels, how vegetation changed from one part of field to the other part of field. It gives us more information, and it means we can do fertilization more precisely. So we have almost everything which we need. Recent satellite images, 2 types of vegetation information. And before we go to the final step, let's think about the issue. Sometimes satellite can't provide us information. Sometimes they don't see, they want to help, but they don't see what is happening on the Earth. Because like there is some barrier. And it's the same case like for people. So we're here and we don't see what is happening in the next room because there is a wall. We can't see through the walls. And for the satellites, walls are clouds. It sounds like a problem, but for the software engineers, for data scientists, it sounds like a challenge to detect cloud images. Because in this case, we can't use the data and they are not really available. And we can do it, actually we do it. So there is many open solutions, libraries, many scientific papers around that. Basically what we do, we just calculate the cloud probability per pixels, then we define the threshold to consider whether it's cloudy or not, and then calculate the cloud coverage. And they decide again whether we can use this field for next steps of analysis or not. Yes, actually we have more challenges like to do approximation of partial cloud images based on the previous images to make it non-cloudy, but it's some ongoing challenges. Up to now, we have a recent satellite image. We have 2 types of biomass information, I mean vegetation information, and we can detect clouds. It brings us to the final step, which is creation of the application map. And as I said in the beginning, when I was talking about the smart farmer who wants to make variable fertilization, application map is distribution of your fertilizer over the field, and it shows how many fertilizer to put in which area. And this decision is made based on satellite data. So if you see many colorful dots, they reflect the amount of fertilizer in the resolution 30 by 30. So red dots reflect more fertilizer, gray dots reflect less fertilizer. So it's almost answering on our talk title, Digital Farming and Fertilize Variably based on satellite data. So I almost conclude, but before to conclude fully, let me to answer on the general question about the industry. What is digital farming now? And from our talk, digital farming now is creating a field. So you can use some tools to draw at your home your field boundaries, like playing the game. You can then easily to fetch biomass information, different type of, you can detect clouds, then you can look where you have low vegetation, where you have high vegetation without going to the field, analyze it and do planning based on your experience, which developed by years, or based on some recommendations, which we can give you as well. And as a result, you can fertilize variably. In the digital farming, you can fertilize variably based on satellite data and recommendations. Thank you for your time. I'm really open for the comments, feedbacks, and any questions. So we have many challenges to solve. That's why we are looking for people that can help us to solve them. You can contact me through the email, LinkedIn, or we can talk later, I think, in the third floor. Thank you for your time.